All right, welcome back to Mr. Fred's Tech Talks. I'm Mr. Fred, and this is the podcast where we make coding, technology, and now artificial intelligence fun, friendly, and easy to understand. It's really a podcast for kids, parents, and teachers too, and anybody who's learning to tech. Now, you know I love kicking off things with sound bites, so let's hear a few classics about learning and training.
Wax on, wax off.
Your mind. You must unlearn what you have learned.
I know Kung Fu.
Just keep swimming, just keep swimming, just keep swimming, swimming, swimming.
Wax on, wax off, unlearn what you have learned. I know Kung Fu, and of course, just keep swimming. Training in the movies really is all about repetition and practice. And that's true for people, but it's also really true for artificial intelligence. In this episode 8 of our AI series, we're going to peel back the curtain and look at how large language models actually learn. And as I teased last time, we'll also talk about what happens when training goes badly and how it gets kind of messy.
Talking about gadgets, games, and gears. AI buzzing in your ears. Parents, teachers, kids unite. We're learning tech and doing it right. Oh, it's a tap, swipe, scroll kind of show where zeros and ones are ready to go. From old school DOS to robots that talk, we're jamming with Mr. Fred's Tech Talks.
Training a large language model is like putting it through the biggest school in the world. As we covered in the last episode, here's what happens. First, there's the gathering of the data, collecting mountains of text in the form of books and articles and websites and social media posts, conversations. But the quality matters. Bad data leads to bad outcomes. Then we get to tokenization, where we chop it up into little pieces, kind of like Lego bricks. And then we do the prediction game, where the model tries to predict the next token. We provide some feedback, so when it's wrong, math kicks in and we do back propagation to adjust it. And this gets repeated over and over and over again, billions and billions of times. It's like practice drills for a soccer team, only on a mind-bending scale. It's a lot. But here's the kicker. You can't do this on your own laptop. You can't do this on your own personal computer. It takes supercomputer level hardware to do this. Inside your computer, we have a CPU, the central processing unit. It's the brain of the computer or your phone, your device. CPUs are like one smart worker, and GPUs are like thousands of workers. That's the graphics processing unit, GPUs. But a GPU, a little bit different. It's like thousands of smart workers working side by side. That's why they're the muscle behind AI training. But GPUs don't really sit alone. They live in what are called servers. Now, a server is basically a heavy-duty computer. It's bigger, stronger, much stronger than your home PC, and it's designed to run nonstop. But picture a slim metal box, though, about the size of a suitcase, packed with processors and memory and storage and cables. But unlike your laptop, it doesn't have a screen or a keyboard. It's meant to sit in a rack, and it works all day, every day. Now zoom out. Instead of one server, imagine racks of them stacked like books on a shelf. Then rows and racks lined up like aisles in a library. Multiply that by hundreds, even thousands, and you've got a data center. It's a giant warehouse, and it's blinking with, lights and humming with fans and buzzing with electricity. These centers generate, though, so much heat that cooling becomes really critical. Now, some use industrial air conditioning, some pump cool water through the pipes, and some are built in colder regions just to keep costs down. Think of this. Each server is a bookshelf filled with knowledge, and a rack is a whole aisle of shelves. A data center is the entire library. It's the entire library building. It's gigantic, it's organized, and it's open 24/7. When you ask ChatGPT or Copilot or Gemini a question, it's like pulling information from hundreds of shelves all at once, faster than any human librarian could dream of. Now, training a chatbot like ChatGPT meant filling those massive libraries with thousands of servers loaded with GPUs, all working together for weeks. But what happens when things don't go as planned. And boy, believe me, in tech, a lot of things don't always go as planned. Sometimes we encounter what's known as bias. So if the training data is full of stereotypes, the AI can pick up on them. For example, if most online text says doctor is equal to he or nurse is equal to she, the AI might assume those roles always match gender stereotypes. It could also encounter something known as hallucinations. AI can sound really confident when being totally wrong. You could ask for a list of books by a certain author, and it might invent a title that sounds real, but it doesn't exist. That's crazy. And then there's something known as overfitting. That's when the AI memorizes instead of generalizing. That would be like when a student would memorize the answers to practice problems, but fails the test when the test changes even slightly. That's why training isn't just about feeding in data. It's about filtering, balancing, and testing. Otherwise, the results will get biased, they'll get made up, or what we'll call brittle. They can break apart. So why does this all really matter? Well, when you chat with ChatGPT, you're not just asking some magic brain. You're using the results of billions of tokens being processed, thousands of GPUs inside the server, racked and stacked up. So the data center, the size of the libraries, but all this stuff is coming together. And then human teams working to clean up the mess when the training goes sideways. It's powerful, but it's not perfect. Just like any student in training, it might be brilliant in one moment, but confused the next moment. All right, so let's check out the tech tip of the episode. Here's something fun you could try. Ask Gemini, Copilot, or ChatGPT a simple question you know the answer to. Then give it a little twist to see how it handles the patterns. Well, let me give you an example. Here's one. It's one of my favorites. Who was the first person to walk on the moon? And it should say, that's right, Neil Armstrong. But then give it a twist. Who was the first person to walk on the sun? Now, you know, it's impossible, of course. But ChatGPT or Copilot or Gemini or Grok might still try to answer because, well, it's in a predicting mode, not checking reality. And that's interesting. Here's another one, though. You could ask it, what is the capital of France? Well, the answer is Paris. But here's a twist. Ask it, what is the capital of the ocean? You'll probably get something imaginative, but not quite factual. I'll give you one last one. What is the chemical symbol for water? Well, it's H2O. But here's a twist to that. What is the chemical symbol for friendship? It may invent something playful, even though chemistry doesn't define friendship. So give that a try. These are little experiments that could show how AI is amazing at patterns, but it also shows that it can wander into bias and silliness. And also that area I talked about was hallucinations, right? All right, and that is the end of episode 8 of Mr. Fred's Tech Talk. We've gone from what is AI to what are large language models, and today, now how do they learn? Next time, in episode 9, we'll dig into the strengths and weaknesses of ChatGPT, and then how to use it wisely. Make sure you subscribe on Apple Podcasts, Spotify, or YouTube, and so you don't miss out. And really, share this out with some friends. Until next time, let's keep exploring, keep coding, and keep asking great questions.
Roads? Where we're going, we don't need roads.